Hi, welcome to the course Machine Learning with Support Vector Machines. This course will cover everything you need to know, from data manipulation to the foundations of the most elegant algorithm in AI. With a focus on practicality, you'll be well prepared to leverage this model for all sorts of problems with application to security and more. SVM is part of the world of artificial intelligence and machine learning. AI is the most general concept here. It refers to a program that's able to process information, make decisions, and solve tasks. Machine learning empowers such program to model the right behavior from data, enabling the machines to learn and adapt. And finally, support vector machines are a type of algorithm that's part of the machine learning toolkit. What does it mean to learn and adapt from data? Well, imagine you want to classify flowers into 3 types based on their petal length and width. On the left image, each point represents an example, a flower. Features 1 and 2 represents the petal dimension, and the color represents the flower type. Machine learning will try to build a model which, based on the feature values, will predict the flower class. This model could be, for instance, a tree which applies a series of conditions on the feature value in order to make a decision. Then this model can be used to make predictions on new data. Imagine you have a new flower. If its dimensions fall into the blue area, the model will predict the blue class. Now, SVM is a sort of machine learning model, just like decision trees or neural network. It was introduced in 1992, and it predicts the class using decision boundaries, which are hyperplane, separating the data. Now, these decision boundaries are adjusted using training data. But because several decision boundaries could separate the class the same way, the model tries to select the one that maximizes the margin with the closest points. This helped the model generalize. Now, we'll come back to all these concepts, hyperplanes, margin, generalization, in details later in that class. Also, over the course of our journey, we'll go through the proper methodology to train and evaluate SVM models. We'll cover the concept of loss function, which is the way to tell how good the model is doing on the training data. We'll also talk about optimization, which is how the model adjusts its internal parameter to reduce the loss. And finally, we'll cover evaluation, which is how we measure how the model does when he makes prediction on new data. On a final note here, the base SVM model is a linear model. It learns to build linear boundaries between the classes. But sometimes the real boundary will not be linear. Fortunately, there exists a method called the Kernel Trick that consists in transforming the data in a way that makes the classes linearly separable so that the SVM can learn. We'll also cover this method in the course. So let's see what's ahead of us on that journey to master SVMs. Before diving into the model itself, we'll solidify our Python foundation, which will be essential for a successful applicative journey. In particular, after going through the basic Python syntax, we'll explore the most emblematic Python libraries for data manipulation. Of course, we'll also cover the scikit-learn library, which is one of the best toolkits for the data scientists and SVM practitioners. Once the fundamentals of Python are covered, we'll dive into the heart of this course with the essential concepts used in support vector machines, in order to deal with all sorts of supervised learning problems. We'll also cover the kernel trick to extend the model to more difficult problems. Then we'll move on to the practice with the proper machine learning methodology to train and evaluate SVM on real-world problems. Finally, we'll cover all the techniques that can improve the robustness of a system relying on SVMs. So get ready to become an SVM expert with hands-on skill to tackle the problems that matter the most to you.